I thought that you really needed to know a bit about source code management systems before the next lab. And so I moved this lecture a bit earlier in the course. And my apologies if you're expecting a different lecture today. Hopefully this one will be just as enjoyable. So we'll be talking today about source code management systems. You've probably met some of those already. In the last lab, some of you would have downloaded the A2PS source code using a tool called Git or another tool called CVS, depending on which archive you used. We're talking a bit about the history of source code management tools, how they're used in the free software community, what the advantages and disadvantages of the different types of tools are, and then you'll be using them in the next lab. So, source code management tools, the early approach, in the early days of free software, very simple tools were used. Basically, the primary ones were diff and patch and tar. And so people would tar up a set of source code and offer it as a tar file to be downloaded somewhere. You would use the diff and patch tools to work out the differences between this source code and that source code, then to apply those differences from one piece of source code to another. Can anyone remember who wrote a diff and patch? Anyone know that? Famous person in the history of free software? No, Larry Wall. Larry Wall's diff patch utilities.
Who also wrote Perl.
Diff and patch are extremely well-known tools and extremely useful, but it's quite a primitive way of dealing with a source tree. So a lot of this lecture will be talking about some of the more advanced tools. The way it basically worked were patches were sent by electronic mail. So when you had a submission that you wanted to make to a project, you would email them a patch file with what changes you wanted. Before we had diff and patch, then what was used? How did you make a contribution?
Send it through tapes.
Send it through
Tapes.
tapes, yeah, you could send a whole new tarball, right? What's inconvenient about that? So I've got a great big project, you know, some source code tree with 1,000 files in it, and somebody wants to make a contribution, and they send me a whole other tarball containing thousands of files in it. What do I do with it?
Yeah. Multiple authors redistribute it out to everyone else. They've got better changes, how they bring it back.
Yeah, you've got to work out how you integrate his changes into your changes. Now, you could just take his whole tar file, but that's fairly inconvenient because you might have made changes yourself since then. So you've got to work out some way of applying just the changes that he wants to make to your tree, to your source code tree, in your own directory. So you need some way of communicating those changes. Yeah, Bob?
I'm wondering if you might have people who might not know what diff or patch actually are.
Yeah, in fact, we're talking in the next slide and showing some examples of different patch and using it. No, that's great. So we'll be learning how to use them a little bit. So each developer in the early days maintained their own tree. By tree, I mean what's called a source code tree. It's called a tree because there's like a tree-like directory structure with like a root and branches coming off. That's a directory system, a directory tree. And so each developer had their own copy of the code. Then they would send patches to each other, and a patch is a series of instructions on how to modify the code to make some particular change. Okay? And in the early days, most distributions of the software was done via simple protocols like FTP, the file transfer protocol. You probably have all seen FTP at some stage, downloaded something from an FTP site, or by using Usenet News, a very popular way of distributing stuff. In fact, comp sources Unix was one of the most popular ways of distributing free software for Unix systems in the early days. Okay, so patches. What is a patch? Well, this is what a patch looks like. So this is an example. Now, this is a real patch that, a very small patch that was made to the Samba source code just a few days ago. And my apologies, that's a bit low on the screen. If you can't see past this lectern, by the way, it might be a good idea to move across in the room so you can see what's going on, because there will be stuff down low on the screen as well as high up. This projectors project quite low, unfortunately. So basically, a patch is a tool for code exchange. There are several different formats, but there are a number of common features between them. And these days, most people have settled on one format, which is called the UniDiff format, right? UniDiff is the universal differencing format. Nearly all patches that are sent around between projects are in a variant of the UniDiff format these days, and this is an example of a UniDiff format patch. It contains a short bit of context for each change. So, do any of you remember the old days with the original diff, how the original diff worked? Have any of you been around long enough to use diff before sort of UniDiff came out? Maybe I should just show you that. Let's do some examples. So let's create a file, and we'll call the file foo.txt. All right? And this is going to be hello world and another line, and here is some more stuff. Okay, we've got three little lines like that. All right? And now we're going to create bar.txt, and we're going to make it a little bit different. It's going to get rid of the L in line, and it's going to change sum to even. Right?
And add a line.
Okay, and add a line. So in the middle here, this is for Bob. Okay, we've added a line. Right. Now we can go diff. We can ask for the difference between these two. Difference between foo.txt and bar.txt. Okay. This is the original differencing format that was used. Now this is, that projector's slightly skewed. If you
No. Move your window.
Move the window. There is a reset button you can do, but yeah, okay. I'll move the window across. Let's see.
Just slide it.
Great. Okay. So what this is saying is these are little less than arrows. This is the old diff format, not the modern one. It's saying remove those two lines and add these three lines. Okay. Now it doesn't contain any context. Given this is a fairly small file, if I make it a slightly larger file, so I'm going to add some stuff here, foo bar, okay, and I difference it again. Then it's showing you sort of what's removed and what's added, but around the lines that are removed and added, it's not telling you what else is happening, what code is close to it. This was the original diff format that was first produced by the very early versions of diff. And the problem with it is it just says add that line, remove that line. So at line 1 to 3, take out these three lines, 7 to 9, add that. What's wrong with this format? What's the problem with this format? What's good about it and what's bad about it?
It's hard for people to read.
It's hard to read, yes, and the newer ones are probably easier to read, but not by a lot. Right? What's some other problems?
It's a lot harder to apply changes if some other change has been made.
Exactly. It's saying at line 7 do this, but my version of the code might have different line numbering because I've added something above line 7. Right? So in other words, it doesn't cope with applying changes where there's already been changes in source code. Now, if free software was all about binary files like images, JPEGs and GIFs and videos, that sort of thing, it wouldn't matter. Because if you change an earlier part of the file, pretty much the whole file changes. But free software generally deals with source code where you can independently change some stuff in an earlier part of the file and a later part of the file. Okay? So you want a format where you accept a change from this contributor, then you accept a change from that contributor, and you can apply both sets of changes without having to wait for the second contributor to get the first contributor's changes before they can generate their changes. So you want the format for delivering patches or changes to source code to be robust to existing changes in the code. But if the existing changes are too close, are right around the same lines, you want to get some sort of warning that there's, okay, these might overlap and conflict with each other. So the newer format, if I choose the UniDiff format -u, right, it gives a little bit of context. So here, for example, is a context line, that one there. This line here has no marker in front of it, meaning that it didn't change. It's the same in both files. But it's included so that when you apply the change, you can see what's going on around it and you can find the right location of the file to apply the patch. And the patch program is smart about searching through the file to try to find where to apply the changes. Okay? So if we go back to this example in my slide, let's see, this patch here, right, this little patch, what this is saying is that this patch changes this file here, service control _nt.c, right? And so the -- here means that's the old file, and the new file is this one. And the a/b is just generated by my source code management system, right? It's making up pseudo names for the old file and the new file. It's really just the same file that's being changed. Okay. It's also saying that this patch applies at when the patch difference was taken. It was around line 466 of the file, spread across 9 lines, and it's going to 466 spread across 7 lines. So you can already tell from that that the patch reduces the number of lines in the source code. It reduces it by 2 lines. This little marker is a very modern a feature of the diff program. Diff didn't originally put this extra at and a little message at the end there. That was added in the quite new versions of diff just in the last few years. Can anyone see what that is? What's that little at and that extra marker there?
Function name.
It's a function name. And so what it's doing is diff now understands a whole lot of different programming languages. So it understands the syntax of the C programming language and a bunch of other programming languages. And it now, whenever it finds it's making a patch, a section of patch, for each section of patch, it goes back up the code and works out what function this is part of, if any, and it puts a marker in there to saying we're changing the following function. Right? That means that when a human is reading this patch, they can work out what function they're talking about. So we know that they were changing the service control enum service status W function. Okay, and it gives you it doesn't give all the header of the function, it just gives you the first few characters of it like that, so you can work out which function it's actually trying to modify. Now that function header might be way up in the file and it's not being modified, right? But it goes back and works out what function you're talking about. Then the rest of this patch, let's have a look at it. You can see this just looks like source code. This is just ordinary C code, but notice these minuses and pluses. Who can tell me what the minuses and pluses mean? Somebody. Have a guess.
What's been taken out, what's been put in?
Minus means removed. So the patch consists of removing that line, and that line, and adding that line. Okay? So you can see as a interchange format for supplying changes to somebody, that's extremely useful. It's basically a way of communicating to them exactly what changes you want to make in the source code. And this works for Java, it works for Perl, it works for pretty much any language you like, any text-based language, right? Languages that use binary format doesn't work very well, but it works for any text-based language. And so this is the basic lingua franca of communicating changes in the free software world. And even with modern source code management systems, people deal with patches all the time. If you look on a mailing list, you'll commonly see things like this being posted saying, I suggest we make the following change, or I would like to fix the following, here's the patch. And you'll see a lump like that. And so one of the things you need to learn how to do is to generate patches like this, apply patches like this. How do you take this and then make the change to the code? Now one way to do it would be to bring up an editor on this source tree and manually apply this change. You could go and find that code. Should we do that? Let's go and take this little example. Service source code control.c. Right, I'll find the latest Samba git combined source 3 RPC server service control.nt.c at about line 466 when it finally brings it up. Right, about there, and you can see that the change, well, it's already been applied, this change, it's now got the mem copy. If we wanted to revert this change, we would take out that mem copy and we would put in if blob length, what is it, greater than or equal to r. Now what's wrong with this process that I'm doing? It's laborious, yes, it's also error prone, extremely error prone, typing it in like this. Right, before diff and patch, this is sort of what people did. They described their changes or sent tarballs or whatever. Okay. Now instead what I can do is I can take that patch and I can use a program called patch. Alright? Program called patch that takes that patch and makes the change for you. And you can make it either forward or reverse. You can tell it to reverse the change or make the change in the forward direction. Minus capital R is past a patch to say do a reverse patch. Normally you do a forward patch. It's pretty rare to do a reverse patch. So if I just undo those changes in this source tree so I don't break Samba upstream when I next commit. And so that that's the basic format, and you'll be, during the lab this afternoon and in the following labs, you'll be working with patches like this. You'll be emailing each other patches. When you make a contribution to a project, you'll very often be contributing a patch like this. Sometimes you'll instead be working with a source code management system that automates all this. And underneath, it's usually shipping around things like patches. Some of them use a slightly different format internally, but very often there are actual patches like this just automatically being transferred between computers to bring them up to date and to make changes. And when you ask a source code management system what has changed recently in the project, it produces streams of these patches. And the developer is expected to be able to read them and understand them. So if I go back to that example, and if I go to my Samba, that same directory, source 4, there you go, and if I say what has happened recently in this project, I type the command there, git log -p, so give me a log. The git command we'll be meeting a little bit later. It's a source code management system called git. Give me a log of what's been happening recently, including the patches. -p, show me the patches. And what this is showing you is all of the changes that have been happening recently in this tree, all in this patch format. So you can see that we removed that line and added that line, and then we removed that line and added that one. So the history of the project is here available as hundreds of thousands of patches. In this project, it's about 30,000 patches per year. And it's been going for 20 odd years. A bit less than that, 18 years. So there's huge numbers of patches that have been generated, and the entire history of the project is encoded in this way. So that's different patch, and they were the basic tools, and incredibly useful tools. They're still fundamental to dealing with free software development, still absolutely necessary, but there are more advanced tools available. And that's really what this lecture is all about, the more advanced tools. But to understand the more advanced tools, you have to really understand the more basic ones first, because they still use these basic tools as fundamental pieces. Okay, another one, diffstat, that I'll show you. So you can see the command there, I mentioned diffstat, on the third line. That's a very useful one to know. What I'll do is, if I generate a bit of a patch, so here's a patch that's happened recently, I can go diffstat x.patch, and that will show me the statistics of that patch. What that means, if I just output the diffstat output, it shows for each file that's been changed, how many lines have changed in that file. All right, so it's a summary of the patch. So you can see here, for example, notice the pluses and the minuses. So this one here, in NDRSVCTL, in this patch, 506 lines of changes, and you can see the ratio, 2 were additions, mostly lines being removed and some things being added. Right? So it's mostly removals. And down here you can see that this file has got larger, it's almost all stuff being added to that file. And similarly down further there's this file got considerably smaller. It lost 960 lines of code, right, in this particular patch. So diffstat is very useful when you get a big patch that includes lots of changes. You might like to get a summary of what's changed. And very commonly when you submit a patch to a project, you're expected to submit at the top of your email the diffstat output so that somebody reading the email can quickly understand the scope of what types of things are changing without dragging all the way through the great long patch. If it's a sort of very short patch, you wouldn't bother. But if it's a patch that affects several files, you would usually include the diffstat output because you're trying to make life easy for the people receiving the patch. Why is that? Why do you want to make life easy for the recipient?
Better chance that they'll incorporate your patch.
Better chance of incorporating. If you don't make life easy for them receiving the patch, what are they going to do with it?
Bin it.
They're going to bin it. They're going to delete it. All right? Some project people won't. Some people would accept it anyway. Some people take different attitudes. Other people will say, send me a properly formatted patch, please. But you've got more chance of getting your change accepted if you format it nicely. And there's an interesting social dynamic going on there, because you're offering something for nothing. Right? Your contribution, nobody's paying you to make that contribution. You are voluntarily making that contribution. And yet your voluntary contribution may be rejected by somebody because it's not quite up to scratch. So there's sort of an interesting social dynamic going on. You know, you wouldn't expect that in the normally in the proprietary software world. Particularly, it may even be that the recipient is being paid full time to work on that project. Won't matter. His attitude from the free software community will be that if you can't be bothered to make the patch well structured and easy to work with things, throw it out. And it's largely because there isn't a shortage of people contributing to most free software projects. There's usually not a shortage of contributors. But there is often a shortage of people with the qualifications to integrate changes and to test changes and to make sure that they're good quality. And so the time of the person doing the integration usually takes priority at the time of the person writing the patch. Okay, so back to the lecture. So that's what a patch looks like. Get used to them, you'll be dealing with them a lot. So sending patches. Here are some common rules on sending a patch. You should use diff -UP. -U is the UniDiff format. -P is the extra little flag that says to include the function name if possible, right? Your source code management tool, if you're using one, will usually do this for you. It's only if you are manually running the diff command yourself that you would have to specify those additional flags. The exception is CVS. The CVS source code management tool, which is one of the older ones, we'll be talking about it a bit more later in this lecture, it doesn't default to -U, at least most versions. So you need to add the -U and -P flags to make it do the right thing. You should include diffstat output if the patch is at all complex. I've shown you how to use diffstat. Diffstat patch file, include that in the email. You need to include an explanation of your patch. So you don't just send a patch, say, with there's the fix. You explain why it's the correct fix, what justification, what is it fixing, if there's a particular bug, is there a bug ID, is there a bug number or something associated with the patch in the bug tracking system for the project, put that number in, explain under what circumstances the patch is important, but don't make it too verbose. It's very rare to write more than a few paragraphs in your explanation. It should be clear from the patch itself. The explanation is sort of gives some guidance to the reader. If you need to give great long screeds of explanation, then maybe your patch isn't simple enough. And maybe you should break it up into separate patches in some way. There are exceptions to this. There's exceptions to almost everything in this. Most projects have a convention that you start the subject of the email when you're sending a patch with square bracket patch square bracket. Anyone guess why that is?
Easy mail filtering.
Mail filtering, that's right. How many emails do you think the busier projects deal with each day?
Thousands.
Thousands, yeah, some of them thousands a day. When you're processing thousands of emails a day, it takes a lot of time. And knowing that you can separate out all the patches easily and just look at the patches and then go back and later look at the commentary and things, that's very, very helpful to people receiving them. So the convention that has arisen is that you usually say patch, and then you give a descriptive subject saying what the patch is for, usually. Not all projects do this. Smaller, less busy projects may not have this convention. Have a look on the mailing list, see what other people have done. Use inline or plain text encoding for the patch. A very common mistake for new people to the free software world is to encode their email as HTML, or to use a strange attachment format, some Microsoft attachment format or similar. Very likely your patch will be binned. It'll be just deleted. Okay? And that's because when you send HTML email, the person receiving it might not be able to display HTML email. Now they could probably work out how to do it, but are they going to bother?
No.
They may not put in the effort. So for example, the emailer that I use does not display HTML. So if somebody sends me an HTML email, I'll try and find one here to see what's, or there's some sort of Chinesey ones or something that I can't read. No, there's not one easy. But if they send me a...
Advertising's always good for that.
Yeah, advertising often has HTML emails. My mailer, which I use, I've been using for a very long time, doesn't display HTML. And so if I get a patch from somebody that has embedded HTML, it takes me extra effort to go and decode it. Now, if I think the patch from the subject line is likely to be very valuable, I might go to the effort of doing that, but I might not. I might just wait for the person to resend it in the right format. Sometimes I might reply to them and say, please resend it in the right format. Other times I'll just delete it and wait for them to resend. Okay? So, back to the lecture. Don't send HTML encoded, break up your patches on logical boundaries. This is another common mistake. People are often, when they first get involved in a FOSS project, they're afraid that their contribution isn't significant enough. And they wait until they've got a great big contribution that changes hundreds of things and they send it in one big lot. What do you think happens?
Too confusing to apply at all. It's too hard to know.
It's too confusing to apply. The rule generally is to send small logical changes and to separate them out. Right? It's common that you might spend a week or two developing a change for a program, then you might spend several hours breaking up that change into logical pieces, bite-sized pieces that the recipient can look at each piece individually and say, yes, that piece makes sense. Look at each little piece of the change and say, yes, that's good, I'll apply that. Yes, that's good, I'll apply that. Each separately, rather than taking the whole thing at once. People often call it dropping a bomb. When you give an enormous patch, a great big change to a project all at once, and it's often a mistake made by people who are just starting off in the free software world, and I think it's partly because they're reluctant to make some trivial change. They think their changes have to be significant. But you should really start off with the trivial ones. Start off, it's often called the janitorial patches, right? The little cleanup ones, the sweeping the bits on the corner, right? Doing some little bit of cleanup. That's usually where people start and get used to the project. And even when you want a larger change, you're making some great big change, you often break it up into little pieces and send each piece. Each piece should stand on itself, by itself, as a separate change, but then it's part of a series of patches that adds an overall feature. The changes, you probably will be making fairly small changes to your projects over the next week and over the following weeks, so very likely you'll only have to send single patches. But if any of you do get involved in sending fairly large changes, be aware that you should split them up. Okay. Check that you've followed the project coding style. Many free software projects have a document that describes the coding style. Where they put the braces, how many tabs they put at the start of a line, how many spaces before or after a brace or not, all that sort of thing. Right? There's lots of different coding styles. There's lots of different religious wars on the coding styles. The rule in the free software world is that the person who started the project or the current project leaders gets to choose the coding style. And everyone else follows that style no matter how weird it is. Right? You follow that existing style. Another common rule is that if you're adding a change to an existing file, follow the style in that file. Okay? Keep the same coding style, the same indentation, the same commenting style, etc. as the existing code. That's to make the end result more readable. Right? So make sure you do follow that style. Some projects automate it. There are tools which will automatically rewrite a piece of code according to the rules of a coding style. Some projects integrate into their source code management system so that every check-in automatically gets reformatted. That isn't so common because automated systems make mistakes, and you don't want a security hole introduced by an automatically reformatting program. So it's not very common, but some projects do it. Be sure you're sending the patch to the right place. Does the project ask you to send the patch to an individual, to the mailing list, to some bug tracking system? You need to look up where patches are normally sent to. A good guide is to look on the mailing list and see where other people are sending patches. The most common thing is to send a patch to a development mailing list. Most projects, or many projects, have a separate user mailing list and another development mailing list, or even multiple development mailing lists for different parts of the project. And you should send your change to the correct mailing list. You might need to do some research on what that correct location is. Okay. Be patient and follow up if need be. Particularly in the higher volume projects, probably the highest volume one is probably the Linux kernel, or maybe some projects like GCC and KDE, some of those are very high volume. There's been some famous cases where Linus goes away on holidays for a month or a couple of weeks, and he comes back and he's got 50,000 patches in his inbox, and he just says, oh, bugger it, I'm going to delete the lot. He just deletes the whole inbox, right? Gone. And he might send out a message saying, hi, I've wiped my inbox. If I didn't apply some patch that was important, send it again. Okay? It is up to the sender to ensure that the patch gets through. It's not send and forget. You don't just send it and assume they're going to apply it. You monitor the mailing list, you look at the next release, you see if it's come out. If they haven't applied it, you don't send them an angry email demanding to know why they didn't apply it, right? You might resend the patch, you might go back and look over these guidelines, did you follow all these guidelines? You might ask in a friendly fashion on the mailing list, I sent that patch to the thing, has somebody had a chance to review that patch yet? Has somebody had a chance to look at it? Is it a good patch? You ask that sort of question, but don't accuse people of not doing the right thing. That just won't work. Remember that in many cases people are doing this voluntarily, and if you start accusing them of not, jumping to your tune or doing what you want, then they'll just start ignoring you. And the ultimate is what's called being kill-filed. Anyone know what being kill-filed is?
Your emails are automatically directed to the rubbish bin.
Right. A lot of Unix systems have a feature called the kill file, where you can have a list of all the people that you just want to automatically discard all their mails from now on. Okay? If you do something really annoying on a mailing list, some people will kill file you. And that means they'll add you to their kill file, and it doesn't matter what you send them in the future, they won't receive it. Now that's relatively rare these days, kill filing, but it still does happen in some cases, particularly in higher volume lists, or if somebody asks some particularly dumb questions. And in that case, the only thing you could do if you've done that is to change your email address and use a different one, otherwise you won't get through. Of course, they may not tell you you've been kill filed. Signed off. Some projects have something called a sign-off mechanism, where you're supposed to add a line to the bottom of the email saying signed off by and your email address. Can anyone tell me what signed off by is for and where it came from? Anyone know the history of that? No? Why do you think? Why would some projects have a convention of signed off by?
Approving or taking responsibility, saying
Yeah.
that, okay, I've acknowledged those changes. If you're doing a sign off of someone else's work, if you're in a position,
Right.
saying that I acknowledge those
Yes.
changes and I approve.
But there's a specific historical event that led to this. Anyone know of a company called SCO? SCO Unix? Heard of it? Okay, it used to make a, well it still does, hardly anyone uses it, but it makes this variant of Unix called SCO Unix, right, for PCs. And they decided that their business was going downhill a little bit, so they decided to sue a whole lot of companies claiming that Linux incorporated a whole lot of their code, which it turns out it didn't. And that lawsuit is amazing enough still going. SCO's is in bankruptcy on its last legs. But anyway, as part of that one thing that came out of that lawsuit was the Linux community needed to be able to demonstrate that when somebody submitted a patch, that they really were authorizing the project to receive the patch. And so now some projects have adopted this system for doing that. What they do is in the project documentation, there is something which says, by including signed off by, you are agreeing to the following license conditions. You are agreeing that you wrote the code, you have permission to write the code, etc. This was drafted by a series of lawyers, right? Those lawyers drafted this little bit of text in the project documentation. And so this is a short form for saying, yes, I agree to those license conditions. Yes, you may. My employer has agreed to me distributing this code, etc. If you've got an employer. And so this is a reaction to a particular lawsuit that happened in the past and accusations of copyright infringement. Now those accusations have since been debunked, but the system has remained. The signed off by system has remained in some projects. Quite a few projects have adopted it these days. There's variants of it. There's also reviewed by and other things that mean different things to the project. But signed off by, particularly the Linux kernel project, has a very particular meaning that is described in the documentation for the source code. Okay, so let's now go and have a look at some examples of this. So what I'm going to do, and it's always risky of course to do live demonstrations, but we'll try it anyway. So let's go and have a look at today's Linux kernel mailing list. So we can see that so far this month, what's the day of the month? 13th or something like that? 14th. There's been 6,416 messages so far this month to this mailing list. This is one of many development mailing lists for this one project, right? So it's a very, very active project. And what you can see here, if I just up the font size a little bit, is that easy enough to read? Yeah, except I'll just move it across so that, shrink the window so it's easier to find the edges up there. Okay, that's close enough. Right, so we can see here, this is the main development mailing list for the Linux kernel, and you can see lots of patches, right? Can anyone tell me what this means, this patch 1-3? Just have a guess. one of three. So this patch is broken up into three pieces. So it's an example of a patch that was logically in three distinct parts, and somebody broke it up, so it's a slightly larger patch. This is the first part of three parts, right? And all of these parts are related to changes in the tracing filters section of the code, and this particular patch adds that, allow user input 2B, and it's cut off there. We can have a look at the patch. Right, so if we go and click on that one, have a look at that individual mail. In fact, this is a discussion of it. What we'll do is, there's been 4 comments on it. We'll go back to the original patch. And, right, so here's a patch. It's got a description of, quite short little description about what this patch does. Suppose we would like to trace all task name 1, 2, 3, but this will fail. Trying this, you get an invalid argument, right? He's trying to fix that. Don't guess the type of the filter, pred, and filter parser, but instead we check it in filter and pred. Very terse descriptions, right? That's common. You don't want to waste people's time reading. You don't put flowery words around it, right? Terse, technical, straight to the point. Okay, the recipient, the people who want to read this are people who understand this code already. I don't know what he's talking about. I've got no idea. All right, I've never heard of that function, never heard of any of these things. Well, I've heard of some of them, but not many. Right, but that's fine. I'm not the intended recipient. The intended recipient is the people who work on this particular piece of the Linux kernel. So those intended recipients know what he's talking about. You don't craft your mail and your patch for the world. Anyone's allowed to read it. But you craft it so the people who might want to apply it are the ones who understand it. Now here's the signed off by. He's saying that Lee Zephan from Fujitsu has said that yes, I'm distributing this patch, I intend it for inclusion in the Linux kernel. It has a diff stat showing it changes just one file, and it adds 26 lines, it adds as many lines as it deletes, right? And here's the actual change. There's the change, it's in this function, isString field, it adds that line, and then down further in the file, it goes and deletes those 2 lines, and then down further still, it adds this code, all the pluses, right? So that's the patch, and that's it. Now notice the patch was included inline, straight text, there's no HTML encoding, there's no fancy attachments, straight inline, which means your email system mustn't munge line lengths and wrap lines and stuff like that. And the attitude in most free software projects is that if your email system does wrap things at particular line lengths and that sort of thing, get a better email system, right? And they'll just reject your patches until you do. Some projects will accept it and accept attachments instead, MIME-style attachments. But if this was a MIME attachment, I wouldn't have been able to just click on this and go and read it immediately. I would have had to go and detach it and open an editor. It would have taken me another 10 or 15 seconds to be able to read this patch. Now, if I'm dealing with hundreds of patches a day, those 10 or 15 seconds add up. So, to make it easy for the recipient, you want them to be able to click on it, read this, and somebody familiar with that code can say, yeah, that looks sensible. Wander down a little bit, say, that looks like a good change, that looks like a good change, good, 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 accept. And it's all over in a few seconds, right? That's the fast workflow that tends to happen. Smaller projects might have a slower workflow and not be quite so strict. The faster and bigger the project is, the stricter it tends to be on these types of things. Okay, these are people replying to that. So here is somebody saying, commenting on that change and saying, and you might like to consider that as well. You thought there was a bug in the patch. So here we are, people commenting directly on the patch without even applying it to the code, because the patch is readable to a programmer. So he's saying that you might have liked to shove that in as well. Other than that, it looks good. Somebody's saying, good patch, but you might have considered that extra thing, right? Then follow up on that, where Ingo says, blah, 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 blah. This also conflicts with somebody else's work. So Ingo, who's one of the better known of the Linux kernel developers, has gone and said that this patch looks good, but he happens to know that somebody else is doing a rewrite of the filter engine, and looks like your patch might conflict with that. So giving a heads up to the other developer and telling the other developer, you two better work out how you're going to work together because your work conflicts with his work. They're both making changes in the same area. Right? That's how it works. Nice and terse, simple explain. It would be nice to hear Tom's opinion. So before he says this is a good patch, you'd like to get Tom's opinion because Tom is the one working on the rewrite of this other section. Okay? And all of this happens within probably a few hours of each other. right? Even though they might be in totally different time zones, when one wakes up you get answers going backwards and forwards. And these 4 people who are chatting may well be in all different countries. If they agree on the change. Once they've all agreed, that change can then be accepted into the particular subsystem of the Linux kernel and eventually accepted by Linus into the main kernel release, and it'll come out eventually, after some time, in new distributions that run on your system. Okay? That's how the process works. And it's all just sending patches. Right?
One question.
Yeah?
If in case both have got some conflicts, both have got the patches who are working.
Yes.
But I won't put my patch there.
Yes.
And that person says, no, put my patch because it's
Right.
a more good one.
Right.
So what will happen? How will we resolve this one?
There's a few ways of resolving it. One is that the maintainer of that section of the code, sometimes there's like a maintainer of the whole project, or there might be a maintainer of a particular section of the code. He'll decide which one goes in. He'll decide which one goes in first, and the other one will have to modify it. Or it just might be first come, first served. Some projects, if person A got their patch in first, person B has to redo their patch. But there are tools that allow them to redo their patch without redoing all the work. The modern source code management systems are very good at doing something called merging. Merging is where you take changes from one person, then you take changes from the other, and the source code management system tries to make them make sense with each other. Right? Now, if the changes are both changing the same lines of code, it'll probably fail and tell you, I can't do it. But if it's changing things in the same file, in some related way, it may well cope with it. So the first thing people tend to use is the merge facility of the code, but then what they do is they then resolve manually any what's called a conflict, a conflicted merge, where 2 changes made overwrite the same pieces of code, and you have to then resolve that conflict by manually editing the code. Yeah, but modern source code management systems are pretty good at this. Keep in mind also that this, for projects like the Linux kernel, this tends to happen very, very rapidly. As you saw, we got those 4 conversations on that change between 4 people, possibly in 4 different countries, happening within a few hours of each other. Right? Very, very rapid development. Most of the projects that you'll be involved with during the labs in this course will have not as rapid development as that. The Linux kernel is extreme in the speed of its development. And so you may well find that comments on patches don't come back for a week or 2, even a month. It just depends on how much time people have got to put into the project and how many developers are available. Okay, so first generation source code management systems. So the original very early ones were RCS and SCCS, and they managed files one at a time. So you could manage one file but not groups of files. And you only had one person who could edit a file at a time. There was no merge capability. It provides the development history, and this is the basics of a source code management system. The key is who did something, what they did, and when they did it. And all the source code management systems record that. And the earliest ones, RCS and SCCS, recorded that on a per file basis, but didn't relate any of the changes between files. If you're a programmer, you'll know that when you change one file, very often you have to change another file to match, right? The RCS and SCCS system recorded each of those changes completely separately. Didn't relate between them at all. After that, the one that dominated in free software for a very long time was called CVS, which was based on the RCS system, and it's called Concurrent Versions System. It's built on top of RCS. It allowed for parallel development. That was the big step forward. So 2 people could be editing the same file at the same time, and they could both then make contributions back, and it would try to merge the results to produce something sensible. Okay? So it included merge and conflict resolution. It was hugely popular, and it still is hugely popular in the free software world. It's getting less so. There's a lot of projects have moved away from CVS now, but there's still maybe 100,000 or more projects out there using CVS, just to pick a number out of the air. Massive numbers of projects still use CVS, including some of my projects. It dominated from about 1991 to 2005. It has many limitations. It's extremely hard to rename a file. Once you've chosen the name, you're stuck with it. Right? You can create a new file with a new name and then delete the old one, but that doesn't give you the history that that was a rename. Okay? It's also very hard to delete directories or rename a directory. Dealing with directories, it was very primitive that way. It's because it was built on top of RCS that only understood individual files. It didn't understand how to track things between files properly, and that ran over into CVS. It also had quite poor branch merging support. Merging a branch is where you take your development tree and you're adding some new feature. So you create what's called a local branch, which is like a very short-lived fork, if you like, of the code. And you do your own development for a while, and then when it's ready, you then want to merge all the changes you've made in private up to the central tree. And you want your source code management system to do most of the work to merge up and cope with everyone else's changes. And CVS, it was laborious. People would sort of take the weekend off to do a merge, right? It would be a difficult task, far too difficult. And that was one of the main things that made people want to move away from CVS, because merging was relatively difficult. Okay, so I'll give you a quick demo of CVS. So what I'm going to do is, one of my projects that I've worked on is still in CVS. If I go to ccache.samler.org, little Ccache project, and there is information here on how to download it, and you can see there, that line says this is how you check out the source code using CVS. Right, so if I want a copy of the Ccache source code, I run that command. And notice it's a fairly obscure command, :pserver, CVS at pserver, it's obscure, right? CVS is a bit like that. It tends to have these sort of obscure ways of doing things. So I'll just get rid of the old copy that I had from before. I'm going to do a checkout of the CVS source code from samler.org by running that command. And there it is, checking it out, all done. It's a nice small project. So there's the source code. Now I can do things to it. I can modify this file, and I'm going to change cleanup.c, and I'm going to delete that structure element. Then I'm going to go down and put it down here instead, and then I'm going to get rid of that function call from there. Okay, I've made some changes. Right? I can now run CVS diff, which says, what have I changed? Show me what I've changed in this project. Okay? Notice it's slow. It took a few seconds. Why was it slow?
Probably had to look through all the files.
Yeah? A lot of the CVS commands, it had to go look through all the files, but a lot of CVS commands actually talk back to the server. You can only use a lot of the commands while you're on the network. And the more modern version control systems allow you to do things while you're offline. Allow you to do a lot of operations. But anyway, showing you the patch. You can see there that it said I've removed that function, I've added that line there, removed that line there, which is a perfectly accurate description of exactly what I did. And notice that this version of CVS produces the unidiff format, which has got some context around it, right? Older versions of CVS, you would have had to do CVS diff -u. I'm not sure if it understands the -p, hopefully it does. Yes, with -p, it's thrown in the function names here, whereas it wasn't doing that. So it isn't by default giving the nice little function names on each one. Okay, so that's how I do that. If I wanted to make a check-in, I would do CVS commit to commit the changes, but I'd have to have permission to write to the central repository, because CVS does everything by writing back to the central repository, and you've got to have permission to do that. So you can't have your own little area where you try things out and commit things and keep logs. Let's have a look at a log. So log shows me everything that's changed. And it's not very useful. CVS output of CVS log, it's accurate, it's complete, but it's not very readable. It doesn't actually give you very good information about what's changed. The more modern version control systems give you much nicer output to show what has actually changed in the code. That's another big reason people have moved away from systems like CVS. Okay, so that's basics of CVS. On the website for the course, there is a summary of the commands for the major source code control systems used in the free software world. So there's examples of the basic commands you would need to know, okay, for sort of a quick start. Centralized versus distributed. So this was a big debate that happened a few years ago in the free software world. Should source code management systems be centralized, where there's a central host that holds all of the repositories, copies of the source code, etc.? Or should everyone have a complete copy of the full history themselves and operate independently? Now, CVS was a centralized system. Newer systems are called distributed systems. And basically, the distributed systems have won. The benefits of the distributed systems tend to be larger than the benefits of the centralized systems, and so projects, there's a strong movement away from the centralised ones to distributed ones these days. But still, probably the majority of free software projects are probably still hosted in a centralised source code management system. Okay, so what does it matter? So CVS hosts in a central fashion. Each developer has a checkout, but each developer doesn't have the history, right? So the central repository holds the full history and interactions between project developers. The individual developers, whenever they want to ask something about history, about who wrote that line of code, what happened here, what changes have been made, they have to have a communication to the central server, which means you have to be on the internet pretty much full time when doing development. Most of the project metadata is stored only on that central server. Distributed version control systems, all of the project history is locally available to all developers, which means you can do nearly every operation on your laptop on a plane without having any internet connection. And that's extremely handy, particularly at conferences with poor internet connectivity, or when you're working at home and you don't want to be sending lots of data to the United States all the time over slow links. Most systems also aim for much easier branching and merging, and the distributed version control systems in particular. They aim to make the job of merging large numbers of changes extremely easy. The workflow of merging in changes has to be very, very fast and efficient. Subversion is, in some ways, the last of the centralised ones. It was an attempt, its logo was CVS done right. So the idea was to take the CVS system and fix up the major deficiencies, the fact you couldn't rename directories, the fact you couldn't produce good logs, all these types of things, and to create a more modern system but based around the same concepts as CVS. It's still extremely wide. It's probably the most widely used one now, along with the legacy one still in CVS. So extremely widely used. A lot of the projects you'll be dealing with this week will be in the Subversion SVN system. It's got a centralised design, it's non-distributed. There were some distributed add-ons, but they're not particularly widely used. In other words, there's an add-on to SVN that tries to make it more distributed. And you'll see how to use CVS in the lab this afternoon. Distributed systems started back in 1997, but they didn't really take off until the Linux kernel adopted something called BitKeeper in around 2002. And BitKeeper was a bit of a strange one in that it was semi-proprietary. It started off actually as more towards free software where it distributed the source code, but it had some strange licensing conditions, a very unusual licensing model that led to a lot of conflict in the free software community. And, but it was an extremely well-designed source code management system, and it had a huge impact on the speed of development of the kernel. It made the kernel bazaar development model much, much more efficient. Much smoother and much more efficient. So we really have to be grateful to the BitKeeper developers for providing this free tool for so many years. Now, since then, there's a whole lot of newer systems, starting in around 2003, a whole lot came out, partly actually because of some conflict that happened around the BitKeeper project, and that conflict was partly due to some work that I did, where I wasn't happy with the licensing model that BitKeeper was under, because the licensing model said that if you use BitKeeper, you cannot develop any other source code management system. You can't work on another source code management system. So if I was to use BitKeeper, I would be saying that I never want to ever work on a better version of Subversion, a better version of some other source code management system. So I didn't find that acceptable, so I never used BitKeeper, but that meant that I wasn't able to then interact with the project in the same way as many other developers. So I decided to write my own BitKeeper compatible tool, which I called SourcePuller. And so I wrote this tool which is completely wire compatible with BitKeeper, so it worked against BitKeeper repositories, but it wasn't based on any of the BitKeeper source code. I didn't have access to any of that source code, so it was a completely independent project. And the authors of BitKeeper weren't happy with what I did at all. There was a big fuss, and you can read about that fuss online. And as a result, they withdrew BitKeeper from use in the Linux kernel community, and that sparked a whole lot of new development, a gap. BitKeeper had demonstrated to the world how good distributed source code management systems could be, and so of course everyone then said, I'm going to write one. And so a whole lot of people around that time, around 2002, 2003, decided to write new distributed source code management systems. And a whole bunch of really good ones came out. We've got Bazaar, Darks, Mercurial, Git, Monotone. The one that's gained the widest following is Git, which was written by Linus Torvalds, the same person who started the Linux kernel. And it's an extraordinarily good source code control system, except that it can be a bit hard to use. You'll probably use it a bit during this week, or you might, depending on which projects you pick. Be warned that it has a bit of the Unix philosophy of it. Unix is user-friendly, it's just very choosy about what friends it has. Git is user-friendly as long as you wrote it, I guess. So it can be a bit hard to use, but it is extraordinarily powerful and very well designed system that has made a huge difference in many projects, and it's gaining in popularity a lot. A lot of projects are now using the Git system. Okay? So BitKeeper and Git, I've already told you a bit about the history of that. We're running a bit low on time, so I won't go into that in any more depth. There's plenty of stuff online if you want to read about that history. There are a lot of source code management interfaces available. Most FOSS developers use the command line interfaces, but there are GUIs, multiple GUIs for each one. If you prefer to use a graphical user interface, you may use one for your favourite source code management tool. But most people use the command line, so when they give instructions on how to use it, they usually give instructions in terms of how to use the command line. The tools tend to aim these days to produce a very fast workflow, so that you can get through hundreds of patches and changes in a very short period of time, not wasting any time at all. The tool is supposed to take all the drudgery and just let your brain operate on what needs to look at in the source code. They often have interfaces into editors, so if you're using an editor, it often supports it so that every time you make a change, you can automatically commit it, that sort of thing. Web interfaces, there's web interfaces for a lot of these things so that you can present your source code changes on a web interface. So if I show you something like Git web, if I go to git.samba.org, the Samba project has now adopted Git, and you can see here, these are all of the various Git trees for the Samba project. So we have a whole lot of separate trees. Each developer in Samba has their own tree they work on. And we can see, for example, that Andrew Bartlett made a change in this tree 2 hours ago. Andrew Bartlett is another Samba developer here in Canberra. And we can see a summary of the changes he's been making, like that. We can see the differences that he's made for that change. So there we are, a nice little interface showing exactly what he's done. He's removed all those lines of code. It's got nice colour. Red means removed, green means added, and he's removed those. So it's just removing a bunch of code. Okay? And his comment, removed, unused, extended DN out files. So these files weren't being used, so he removed them. Right? So there's these web interfaces that are very commonly used to source code management systems these days. And it's a good way of browsing around the project to see what's happening. So you should look for it for your project. There's also interfaces with bug tracking systems. A lot of source code management systems will integrate with the bug tracking system, so that when you fix a bug, it's linked to in the source code management system and vice versa. A lot of them also have integration with build management and build farms. And I thought I'd show you what a build farm is. So anyone guess what a build farm might be?
Computer set up to do source code builds.
Yeah.
Remotely, usually.
Yeah. And what's the idea? I mean, how do they work? I'll just show you one of them while we're having a look. build.samba.org. Well, the idea is to automatically find bugs. So we have a set of about 30 odd machines, volunteer machines from all over the world, and those machines are constantly building the various Samba projects. So I can look at the Samba test master recent builds, and I can see all of these machines, these volunteers' machines, and it says how long ago it last tried to build it. So every time anyone does a commit into Samba, all of these machines pick up the commit, try and build it, compile it, configure it, compile it, install it, and test it, run the full test suite, and then report their results back to this website. So we can see that 1 minute ago, an HP UX box called HAPE, running the GCC compiler, compiled that revision of the tree and produced that status. And this particular status means that it configured OK, it compiled OK, it installed OK, but then the test status, the tests failed. It didn't get through the test suite, right? And we can see all the different errors that are happening. This sort of 14 here means 14 tests out of about 400 or 500 failed. So somebody's checked some stuff in that breaks some part of this tree recently. We can see panics where with timeouts and that sort of thing. We can then look at the details of this. So we can go and click on this and see exactly what happened on that machine. And you can see all of the output of the build from this machine. This allows the developers to ensure that their code is portable, to ensure that it works on different operating systems, on different hardware architectures, etc. And this particular system automatically sends email to the person who did the commit. If their commit broke something, they automatically get an email to say, hi, you broke the build on this system, please look at this URL to see what's changed. This is a very, very effective way to improve the quality of your software using build farms like this. It takes advantage of the free software community's willingness to volunteer machines into build farms like this.
Go back a screen.
Go back a screen here. Yep.
Yeah. Go down a bit.
Yep.
Click on the one that stopped at 14th.
You mean, you want to bring the machine that we've got here?
Down to, up.
Yep, this one.
A bit further, there, that one.
Yeah, so this machine is called Trish, strangely enough. I didn't name the machine, even though it's my
Funny
name.
name for a machine.
But I didn't choose the name. Anyway, that machine is here in the labs, is here in this building. And it's a PowerPC machine donated by IBM for use for all sorts of projects, but including running in the build farm here. Okay, so that's what a build farm is. There's lots of different build farms available. The Sando build farm is used by some projects. The Tinderbox build farm is pretty widely used, and BuildBot is becoming very popular now. So there's competing build farm systems, right? In the free software world, there's almost never just one of anything. There's usually competing things. People think they can do it better. Public source code management hosting. This is something you may find useful. Distributed systems, you don't have to get an account on a centralized system, but you often want to publish your changes using a distributed source code manager. So it's useful to be able to store all the changes you've made, store your tree somewhere where everyone else can see it, so you can point them at it. And there's a whole lot of people who have now set up free systems for storing free software. So if you're using Git, repo.oz, I think it's oz.cz, yeah, I think it might be right, or github.com are very useful. I think you mentioned GitHub on the discussion forum. This was the original one that first came out. GitHub was a later one. For Mercurial, bitbucket.org and freehd.org. For BZR, there's launchpad.net. These are all projects that will host your branches, host your repository for you for free for your free software project. And extremely useful. So if you need a place to store your free software project, have a look at one of these. There are also tools to convert between source code management systems. Now that there are so many in wide use, there are tools around that will take the code in one source code management system and convert it to another, usually preserving all the history and the commit messages and all that sort of thing. And they're quite useful if you're moving between one system and another. Okay, so that's about it for this lecture. So we've gone a little bit over time. We're now going to go back to the lab, and you're very welcome to continue the first lab, the ATPS lab, if you haven't got through it yet. I have noticed that only 8 of you so far have subscribed to the COMP8440 mailing list. So please do remember to subscribe to that mailing list, and using the instructions on that first lab sheet. That's because you'll need to be on that mailing list in order to be able to complete the exercises in the second lab. If you're having trouble subscribing, please ask Bob or I to help. If you don't get through all of the second lab today, we'll be finishing up just before 5:45 or so. If you don't get through it, don't worry. You can continue with this lab tomorrow. That's fine. In fact, I suspect that most of you probably won't get through all of this lab today. It's taken a bit longer to get through the labs than what we expected, but we've got plenty of time. We can make up for it in later labs and shorten the project work slightly. So hope you enjoy it, and go to it.